Okay, we are solving systems by our last method, which is elimination. You'll see me call this big addition, and you'll see why in just a second. Okay, the best time to use this method is when both equations are in standard form. AX plus BY equals C. So the best time to use this is when both equations are in standard form. That was good. Okay.
Who threw that?
Nobody. It fell. Okay, zero pairs. Examples of zero pairs. If I have 3x, what would cancel 3x?
3x.
3x cancels 3x?
Oh, no.
What would make 3x equal 0? A negative 3x. Okay, what would cancel a negative 4y? Positive 4y. Will two negatives ever cancel each other?
No.
Will two positives ever cancel each other?
No.
No. Okay, so a zero pair is when they match, except one's positive, one's negative. Okay, so the whole point, good lord, of this unit is to create zero pairs so they match. Yes? So if we're looking here, I don't have any zero pairs, but if you look at our practice, like look at this one. Do I have a zero pair right away? Yeah. Yes. Okay, so sometimes we don't have to multiply, but sometimes we have to create a zero pair. So this is what we want to happen. Do you see how these match? So we can cancel those out. So here we don't have anything that matches yet, but I always look at my smaller numbers. Can 3 turn into 9?
Yes.
Can 2 turn into 5? So we're going to focus on x's, okay? What do I need to cancel a positive 9x? A negative 9x. How would I multiply to make that a negative 9x? Times negative 3. So I'm going to multiply this top equation by negative 3. And I have to multiply everything. So that becomes negative 9x minus 6y equals, I don't even know. Goodness gracious. Negative 42. Okay, so then we're going to rewrite that second equation. Okay, so, yeah, thank you. So I'm going to rewrite the second equation. I have 9x minus 5y equals 31. And this is why I call it big addition, because I'm going to put elementary, you remember elementary math when you did the math problems up and down? That's what we're making it look like. What's negative 9x plus 9x? 0. I always want a zero pair. If I don't have a zero pair, y'all, we're wasting time. Okay, we're just creating a third equation, and that's a waste of life, okay? What's negative 6y plus negative 5y? Negative 11y, and then negative 42 plus 31 is also negative 11. Now can I solve for y?
Yeah.
Yes, what do I do?
Divide.
Divide both sides by negative 11, and what does y equal? Positive 1. Two negatives makes a positive. So half of my answer I have now, y is 1. Now this is where it actually goes back to substitution. So guess what we're going to do to find x? We're going to plug it into one of the equations and solve by substitution now. So this is a twofer. Okay, so if we know y equals 1, I can pick one of the originals. It doesn't matter which one. I'm going to use the first one because it's smaller numbers. I have 3x plus 2y equals 14. And I'm going to replace y with 1. Everybody okay with that? So I get 3x plus 2 times 1 equals 14. What's 2 times 1? Now, how do I solve that? Subtract both sides by 2. I get 3x equals 12.
4.
Divide both sides by 3. And I get x equals 4. So my answer is 4, 1. And because it's an ordered pair, we put it in parentheses, yes? These are also actually super simple to check your work. We're going to use the originals. 3 times x is 4 plus 2 times y is 1. What should it equal? 14. Did it work? Yeah. 9 times 4 minus 5 times 1. What did it equal? 31. Did it work? Yeah, so there's my answer and I'm right. Okay, if we were talking about kind of system, this would be independent and consistent because there's one answer. Yes? Okay, look at example 2. Looking at my smaller coefficients, does 6 turn into 8? No. Does 3 turn into 5? No. So we can still do elimination, but we have to multiply both equations. Now, I'm going to look at the y's because right away I see that I can multiply 3 and 5 and get 15, right? Okay, I don't look at 6 and 8 and know that it just doesn't pop in my head like it does with 3 and 5. So I'm going to make one be a positive 15 and one be a negative 15. So let's go ahead and just focus on positive. How do I turn a 3 into a 15? Multiply by 5. So I get 40x plus 15y equals 41, 205. Now, what would I multiply on the second equation? Because now I need a negative 15y to cancel. Negative 3. Okay, so negative 3 times 6x is negative 18x. Negative 3 times 5y is negative 15y equals negative 3 times 39 is negative 117. Do I have a zero pair?
Yeah.
So let's set it up as big addition. So we can eliminate the y's. Bless you. Yeah, you have to have a positive and a negative, or they don't cancel. Sometimes. So sometimes you're just multiplying them by each other, but not always. Like on the first one, we weren't. Okay, so 40x plus negative 18x is 22x. That's zeroed out. And then if I give this one, and 205 plus negative 117 is 88. Now what? Divide both sides by 22, and I get x equals 4. So now again we pick one of the originals. Does not matter which one. I'm going to pick the second one. And I know 6x plus 5y equals 39. And because x equals 4, I can replace x with 4. So I get 6 times 4 plus 5y equals 39. What do I do? Yeah, what's 6 times 4?
24.
Now what? Subtract 24 from both sides. And I get 5y equals 15. Now what? Divide both sides by 5. And I get y equals 3. So my final answer is what? 4, 3. Inside parentheses. Not fancy brackets, not square brackets, parentheses. Because it's a point. It's an ordered pair. Okay, let's look at example 3. Okay. Doesn't matter what we cancel. We have 15 and 10. 10 doesn't go into 15. Like 10 can't multiply to give you 15. 8 can't multiply to give you 12. So we're going to have to multiply both equations again. I know that 15 times 2 is what? 30. Can 10 turn into 30?
Yeah.
So let's focus there. So I'm going to multiply the first equation by 2. And that gives me 30x minus 24y equals 36. Now, what would I multiply 10x by to become negative 30x? Negative 3. So negative 3 times 10x is negative 30x. Negative 3 times negative 8 is positive 24y, because two negatives makes a positive. Negative 3 times 12 equals negative 36. So I set it up as big addition, and what happens?
They all cancel.
They all are zero pairs. So we get 0 equals 0. True or false?
True.
So what's my answer? Not all real numbers. IMS. Infinitely many solutions. A lot of people did, not just you. The reason it's not all real numbers is because you can't plug in any number in the world and it's going to work. Does that make sense? The only solutions are the actual solutions on both of the lines, but every point on the line is a solution. That's why it's infinitely many. Okay. So let's look at example 5. It's already set up for us, but it's a conversation I want to have. So same concept as that one. Do I already have a 0 pair?
Yeah.
So do I have to multiply anything?
No.
No. This zeroes out. What happens here? This also zeroes out. Does this zero out?
No.
So I get 0 equals 22. True or false?
False.
So what's my answer here?
No solutions.
So that's your difference and what's going to happen for your special cases. Okay, so these are your special cases. Any questions with those? So just like before, true is IMS and false is no solution.
Is this something that's a Monday? It's like just a Monday.
Similar, no, not really. Okay, look at example 4. What's wrong with example 4? Are they in standard form?
No.
No. Okay, standard form is when x and y are on the same side. Okay, so I need to move this y on the same side as the x. How do I do that? Minus y. So I'm going to do minus y, and I get 4x minus y equals 5. I moved the equal sign to the other side so it lines up. Now what's wrong with the second equation? The y's in front. So that's a positive 3y, so I need that to go second. And what should go first? Negative 8x equals 7. So we just kind of flip-flop them. Now is it set up for me to do elimination?
Yes.
Or big addition, whatever you want to call it. Yes. So again, to figure out what we're going to multiply by, I'm going to look at my x's. Can 4 turn into 8? So right away we can cancel our x's. But this is technically negative 1. Can 1 turn into 3? Yeah, by multiplying by 3, right? So it doesn't matter which one I cancel.
No.
Guess what? You're going to get the same answer no matter what. I usually, if I notice I can cancel the x's, I don't even look at the y's. So it's whatever you want to do. What would I need to multiply to cancel the x's? The first equation by just 2. Why not negative 2? Because the bottom's already negative. So I need a positive 8. So this gives me 8x minus 2y equals 10. And I'm not going to rewrite that second equation because it's still there. And what's my 0 pair? The x's. What's 3y plus negative 2y? 1y. And what's 7 plus 10?
17.
So I have half my answer. I'm actually going to pick that first equation because I feel like it looks easier. So I have y plus 5 equals 4x. So I'm going to replace y with 17. So I get 17 plus 5 equals 4x. What's 17 plus 5? 22 equals 4x. Now what? And I get x equals, if I leave it as a fraction, it's 11 over 2. But technically if you type 22 divided by 4 in your calculator, you get 5.5 without rounding. So I'm okay if you use a decimal as well. However, what if it gave you like 5.3 repeating? Am I okay with the decimal? No. And guess what? If you get a decimal and you round it and you plug it in, you're not going to get the right y either. Okay? So just be super careful. If it's a decimal that is repeating and you have to round, leave it as a fraction. Okay? So there's my answer. You could do 11 over 2 or 5.5. I don't care which way you write it. I like fractions for some reason. And there's my answer.
What is this now?
Who knows? You should hear it 7th period. It's like elephants running. Like this circus. I don't even know. Okay, look at this one. We're not going to go all the way through this one. We're just going to talk about the fractions. What do I do to get rid of fractions? I need a common denominator. So I always look at my biggest denominator. My biggest denominator on the first equation is 100. Can 25 turn into 100?
Yeah.
Can 50 turn into 100? So we want a common denominator of 100. 50 times 2 gives me 100. 4 times 25 gives me 100. So when I rewrite this equation, I end up with 2x over 100 plus 4y over 100 equals 9 over 100. And what do I get to do? I get to cancel the denominators. And the reason it works is because if I multiply this whole equation by 100, multiplication cancels division, and that's why we end up with 2x plus 4y equals 9. Does that look way better than what we had? 100%. So that's all we're going to talk about on that one. There is actually one other thing I want to talk about. We're not going to solve for it, but I'm going to give it to you. This is how the district asks a lot of questions for these types of problems. If I need you to cancel x's, and we have these two equations. What are we going to do? Okay, so I just wrote the same thing twice, but looking just at the first one, if I tell you you have to cancel your x's, what are you going to do? Huh? Multiply which equation by 2? The bottom one. By positive 2 or negative 2? Negative, because we have a positive 2, and the way to cancel a positive 2 is a negative 2. I can turn this, because technically that's a 1, right? I can multiply by negative 2, and then that would cancel. Okay, looking at canceling y's. Okay, do I already have a positive and a negative?
Yeah.
So do I need to worry about negatives at all? No. But what can 4 and 3 both turn into? 12. What do I multiply 4 by to turn into 12? 3, and then 3 times 4. So that's all you would multiply by to cancel x's and to cancel y's. Honestly, if we were solving it all the way, I would tell you to cancel x's because it's less work. Okay? Less room for error. Okay, last one. We're not going to go all the way through that either. We just wanted to talk about what we would multiply by. So let's look at this example 6. Okay, it says the Miller and Benson families went to a theme park. The Millers bought 6 adult and 15 child tickets for $423. The Bensons bought 5 adult and 9 child tickets for $293. Find the cost of each type of ticket. What are we looking for?
The cost of each type.
So A stands for what? The cost of adult ticket. What does C stand for?
The number of
Cost of child tickets. We already know how many. We don't know cost. Now, there are sentences in here that we don't need, like this first sentence. Does that tell us anything for this problem?
Yeah.
No. And then here's my question. Find the cost of each type of ticket. So now let's write the equation for the Millers. Okay, it says Millers bought 6 adult tickets and 15 child tickets. So 6A plus 15C, and they spent $423. When writing equations in standard form, it's always a total at the end. Okay, the Bensons bought 5 adult tickets plus 9 child tickets, and that gave us $293. That's your total. So, what do we want to cancel, A's or C's?
Don't matter.
It doesn't matter, but which one do we want to do? A's. What can 5 and 6 both turn into? 30. 6 times 5 and 5 times 6. Remember, you can always multiply them by each other, and it'll always work. Now, that's both positive, so it doesn't matter which one I make negative.
No.
So I'm just going to make that bottom one negative. So when I multiply 5 times 6A, I get 30A. 5 times 15C is 75C. And equals 5 times 423 is 2,115. Negative 6 times 5A is negative 30A. Negative 6 times 9C is negative 54C. And negative 6 times 293 is negative 1,758. Now do I have a zero pair?
Yes.
So it's ready for me to have a big addition problem. That zeroes out. 75C plus negative 54C is 21C. 2,115 plus negative 1758 is 357. Now, how do I solve that? Divide by 21. I get C equals 17. And now we have to use one of the equations, one of the originals, doesn't matter which one, I'm going to use the second one because it has smaller numbers. 5A plus 9C equals 293, and we're plugging in C is 17. Goodness gracious. Okay, so that gives me 5A plus, if I multiply that, I get 153. And that still equals 293. Okay, and then, what do I do? Subtract both sides by 153. And I get 5A equals 140. Divide by 5, and I get A equals 28. So what's my final answer? $28 for, it's back there, adults, and $17 for kids. Now, what if my question wasn't how much for each ticket? What if it said the Cumberledges are going and they're taking 2 adults and 3 kids? How much would they spend? Could we also figure that out?
Yeah.
Yeah, well, we know 2 times the adult ticket plus 3 times the kid ticket, and I would spend $107. Does that make sense? Okay, couple things. If you look at number 1, do you have to multiply anything on your practice? No, you already have a zero pair. If there's already a zero pair, do not multiply. Yes? Okay, if you flip to the back and look at number 1 on the back, it says do not solve. Number 1, just set it up. However, if you solve it, it's a bonus points. Yes? Cool. This is what you're working on. If you have questions, what should you do?